What if the celestial bodies the James Webb Space Telescope has recently observed are not native to our own cosmic expanse? Could the light now reaching us be traversing the very frontier between distinct realities? And what if, just perhaps, the event we call the Big Bang was not an origin, but rather an emergence from something far grander? Today, we delve into one of the most profound and challenging concepts ever contemplated in the realm of astrophysics. This is a theory compelling even leading scientists to reevaluate the fundamental nature of existence itself. So, what precisely did JWST uncover? It all begins with the James Webb Space Telescope, humanity's most advanced instrument for observing the universe. Designed to peer deep into cosmic history, JWST possesses the capability to capture light from galaxies that materialized mere hundreds of millions of years after the Big Bang. However, when the initial deep-field images were processed, astronomers were left in a state of profound astonishment. They detected fully formed galaxies radiating brightly, exhibiting complex structures, and possessing immense mass. These appeared at a period when the universe was expected to be a turbulent and nascent environment. Some of these ancient galaxies are so vast, so luminous, and so densely packed that their very existence at such an early epoch in cosmic history seems impossible. Initially, scientists speculated there must be an error in their data. Perhaps the redshift measurements were inaccurate, or the galaxies were not as distant as they appeared. Yet, as more data accumulated, the consistent pattern became undeniable. These were not merely isolated anomalies. This represented something far more perplexing. And that is when a truly astonishing idea, long considered fringe, began to gain renewed consideration. An idea that could potentially explain everything if one is prepared to venture beyond the confines of our known universe. Consider this profound notion. Our entire universe, every galaxy, every atom, every one of us, could be contained within a black hole. Not orbiting one, not merely near one, but existing entirely inside it. Does this sound utterly improbable? Within the framework of this theory, what we refer to as the Big Bang was not the ultimate beginning. Instead, it marked the precise moment a colossal star collapsed into a black hole within an entirely different universe. The singularity, that infinitely dense point, did not solely compress matter. It simultaneously gave birth to a new reality on the opposite side of its event horizon. From an external perspective, it would appear as a black hole. However, from an internal vantage point, it would manifest as an expanding universe. If this premise holds true, then the galaxies JWST has recently identified could represent the initial indications that our cosmic enclosure is not entirely isolated. Instead, it might remain subtly connected to the parent universe that lies beyond. Here is where the implications become even more extraordinary. Some of the galaxies observed by JWST appear to be excessively luminous for their age, emitting energy in ways that conventional cosmology struggles to account for. Others seem to warp or distort light in peculiar fashions, as if an immense yet unseen entity is situated between us and them. Typically, we would attribute such phenomena to gravitational lensing, the bending of space-time caused by mass. However, a select few of these anomalies do not correspond with any known cosmic structures. It is as though the light itself has been modified by something operating beyond the established physics of our universe. This is precisely where the black hole universe concept begins to transition from speculative fiction to a potentially viable scientific explanation. If universes can indeed originate within black holes, then our own cosmic neighborhood might be an integral part of a nested hierarchy of realities. Universes contained within universes, each successively giving rise to the next. And JWST may have just captured the very first indication of this profound connection. To maintain a balanced perspective, it is important to acknowledge that not all scientists are prepared to discard established cosmological models. Mainstream astrophysicists have articulated significant objections. They contend that the galaxies JWST is observing might only appear ancient because our interpretation of their light signatures is flawed. Perhaps interstellar dust, gas, or novel star formation models are misleading our measurements. Others propose that dark matter and dark energy, two fundamental forces we still barely comprehend, might be influencing these galaxies in unforeseen ways. In such scenarios, there would be no necessity to invoke the existence of another universe. Nevertheless, even the most skeptical voices concede that these new findings are compelling scientists to fundamentally reevaluate the speed at which structure formed in the early universe. Something is undeniably amiss, and it is often when the mathematical models cease to align that the most revolutionary scientific breakthroughs tend to emerge. So, what if the explanation is not a black hole at all, but something even more expansive? Another hypothesis gaining considerable traction suggests these galaxies could belong to an entirely distinct universe, one that potentially overlaps with our own. In a multiverse framework, our cosmos is not singular. It is merely one bubble within an infinite cosmic ocean. Occasionally, these cosmic bubbles might collide, merge, or even subtly intermingle, leaving behind faint imprints in radiation, energy, or the very fabric of space-time. Some cosmologists theorize that JWST might have inadvertently captured light originating from one of these cosmic interactions, a kind of cosmic bruise imprinted upon the structure of our universe. Imagine the implications of that. The first photographic evidence, not merely of another galaxy, but of another reality altogether. And here is the truly astonishing part. If this theory proves to be accurate, then the boundary of our universe is not a definitive edge. It is, in fact, a gateway we have finally peered through thanks to the extraordinary capabilities of JWST. Now this is where the implications become truly mind-bending. If our universe is indeed connected to a parent universe, or to one existing in close proximity, there might already be subtle signals leaking through. Some physicists point to enigmatic energy pulses and faint gravitational wave patterns that do not conform to existing models. Others speculate that the dark energy responsible for our universe's accelerating expansion could literally be energy seeping in from an external source. In essence, the expansion of our universe might be propelled by forces originating beyond our cosmic horizon. And if this is true, then those galaxies observed by JWST, those strange, seemingly impossible beacons of light, could be cosmic fingerprints from a reality that ultimately gave birth to our own. If that concept does not send a shiver down your spine, then perhaps nothing will. So, what is the ultimate truth? Are we witnessing the initial evidence of a multiverse? Are we existing within a black hole nestled in a more expansive cosmos? Or have we simply misinterpreted the fundamental nature of the universe we inhabit? At this moment, we do not possess definitive answers. However, one fact remains unequivocally clear. JWST has irrevocably shattered the perceived limits of what we believed was possible. Every image it captures, every data point it collects, every peculiar new galaxy it unveils brings us closer to resolving the most ancient question humanity has ever posed. Where did we originate? And are we truly alone in this vast cosmic tapestry? Perhaps we are not merely inhabitants of a single universe. Perhaps we are an integral part of an infinite chain of creation, stretching boundlessly outward. And somewhere beyond that cosmic horizon, another observer might be gazing back at us right now, contemplating the very same profound questions.